Greetings, learners. Welcome back. This is Ibrahim Ajame MO2S. Please don't forget to subscribe, share, and follow for more videos. I see. So this is another interesting question on the velocity time graph. I see. Velocity time graph that is under motion. So we are asked to find the maximum velocity using the velocity time graph given. It is already sketched. I see. So that is for A, and B says the acceleration, C the total distance traveled, acceleration in the last 2 seconds. I see. So this is just simple as that. So let's find out, or let's solve it out. I see. Yes, so we have A. A says the maximum velocity. Or maximum velocity. We are asked to calculate the maximum velocity. So now, if you look at the velocity time graph, the graph given, the coordinates or the values on the y-axis are the velocity, the values of the velocity. I see. While the ones that are on the horizontal is the values for the time. I see. In seconds. This one is in meters per second. This one is in seconds. I see. So to find the maximum velocity, we go to the values on the vertical axis, which is the velocity time graph. The velocity. I see. To find the maximum value, you can see that our velocity here is what? Is 10. I see. So that's our maximum what? Velocity from the graph given. I see. So this is our initial velocity. I see. This is our initial, and this will be what? The final. So the maximum. I see. That's the the highest velocity. I see. So it's 10 meters per second. Always indicate the unit. Don't forget the unit. So this is the unit of what? Velocity. 10 meters per second. I see. That is our maximum velocity. So we move to B. B says what? The acceleration. Acceleration. Yeah. So acceleration is change in velocity over the time. I see. Change in velocity, which is V minus U over T. V minus U over T. This V is the final velocity, U is the initial, and T is the time taken. So from the question, our A is equal, so our final velocity, which is what? 10 meters per second, minus the initial, which is 0. Remember, this is the acceleration. From here down to here is our acceleration. I see. So now to find the final velocity and the initial velocity, this is our final velocity. I see. And this is our initial velocity, which is 0. I see. Because it started accelerating here. I see. So which is 0. All that over the time taken. I see. The time taken when accelerating from here, from its initial to its final, is what? Is 5. I see. So it's 5. So we said our A is equal to 10 minus 0, that's 10 over 5, which gives us 10 divided by 5 gives us 2. So it is 2 meters per second square. You see, it's 2 meters per second. This is our acceleration. It's different from the maximum velocity. It is in meter per second. I see, it's in meter per second, while this one is only in meters. This in meter per second square, while this in meter per second square is acceleration, while this velocity is in meter per second. I see. So that makes it different. It's the unit that makes it different. So now we have the letter C says what? The total distance traveled. Now to find the total distance traveled, let's solve it out. Sorry. Now to find the total distance traveled, which is C, total distance traveled. You see, to find the total distance traveled, remember area on a velocity tank on the velocity diagram represents its distance. I see. So area on the velocity diagram represent what? Its distance. I see. So these are the figures of the area of the figures. I see. You can see this one is a triangle, a rectangle, and a what? Triangle. I see. Yes. So to find the total distance, we say d1 plus d2 plus d3. I think because here we have in d1, this is our first distance travel, this is our second distance travel, and this is our third distance travel. So that will be d1 plus d2 plus, of course we have, if you have another about figure or area given, we are going to say it for distance travel. So we are only given three figures here. It is d. So that will be the d1, d2, and d3. I think. Now we first find d1, that is the first distance travel. The first distance. So the first distance here, you can see that it is what? A triangle. I see. So we are going to use the area of the triangle to find the first distance. And remember the area on the velocity triangle represent its distance. I see. So we are going to say the area on the velocity triangle is the same as the distance. I see. So which is the formula is half times the base times the height. You see, that's the formula of a triangle. So this will give us 1 over 2 times, what is the base from the question here? This is our base, which is 5. The difference there from 0 from 5, that gives us 5. So we are going to say 5, that is the base times the height. What is our height here? That is this is our height, which is what? 10. So we simplify this. d1 is equals to equals 1 into this 10 is 5 times. So 5 times 5 gives us 25 meters. So our first distance, the first distance travel is 25 meters. I see. Don't forget the unit. Yes. So we move to d2. D2, you can see that d2 is a rectangular in shape. It is rectangular in shape. I see. So we are going to use the area finding of the area of a rectangle. The formula finding the area of a rectangle to find d2. I see. So what is the formula? The formula is length times the breadth or the width. I see. Length times the breadth or the width. Which gives us, what is our length from the question? Remember, the length here, to find our length here, is going to be the difference of this. I see. 8 minus 5 gives us 3. I see. Then we move on. So if here is 3, remember this one is also 3. If here is 3, this one will also be 3. I see. Here will also be 3. So remember, this our height, which is what? The velocity. It's the same thing here. I see. So it's 10. I see. Which is this 10. I see. So our length here will be the 10 times the base, which is 3. Okay. Our height is, our length is 10. So the length and the breadth is what? 3. So 10 times 3 gives us 30 meters. That is our d2. Okay. Now we move to the third distance. It is d3. Our d3. Our d3, that is also a triangle. I think, look at this here. It is also a triangle. So which is the same thing, half times the base times the height. Half times, what is our base from the question? That is the difference of this, which is what? 10 minus 8 gives us 2. That gives us 2. So it's going to be 2. Times the height. The height is still what? Still 10. I see. Times the 10. I see. So this gives us, when we simplify this will give us 2, cancel these 2, we have 10 meters. I see. So our d1 is 25, D2 is 30, and D3 is 10. So now the total distance now, the total distance traveled will be D1 plus D2 plus this. That is, we add this plus this plus this. That is 25 plus 30 plus 10. So if you add 25 plus 30 plus 10, that is 25, 30 plus 10, that gives us 40. 40 plus about 25 gives us 65. I see. Meters. Don't forget the unit. Huh? So this our total distance travel is 65 meters. Don't forget the units. Huh? Yes. So again, we move to the last part or the last question. Deceleration in the last 2 seconds. I see. Deceleration is the same as retardation O. I see. That is the negative of acceleration. I see. It's retardation. Huh? Yes. So now, deceleration, to find the deceleration here, so our deceleration, just letter D, sorry, deceleration, I see, our deceleration. So now, deceleration is the, we said final velocity minus the initial ordered over the time. It's the same as the acceleration, the formula find acceleration. But here you have to be better. This is our deceleration. You see, this acceleration, while this one is deceleration. You see. So now, what is our final, our initial velocity here is 10. I see. While our final is 0. I see. Is our final here will be 0 minus the initial which is 10. I see. Over what is the time? The time they said in the last 2 seconds, our time will be 2. I see. The last 2 seconds. Of course, the distance from here to here is 2. I see. So now we move on. We say deceleration is equals to, this is negative, I see, 10 over 2. That gives us negative 5. I see. So remember, we are not going to use this negative sign. I see. So our final solution will now be what? Positive 5 meters per second squared. I see. We exit out or remove out the negative sign. I see. So this our acceleration is 5 meters per second. Sorry, deceleration is 5 meters per second square. You see. So thanks for watching. Please don't forget to subscribe, share to your learning colleagues, and then follow more on questions like this. Thanks for watching. Bye.